Hello, respected judges, mentors, and everyone present. We are Twin Tech Girls, and today we're excited to present our project, Malicious Threat Scanner and Response System, an AI assisted endpoint security platform designed to continuously monitor system behavior, detect suspicious activities in real time, validate threats using external intelligence, and support rapid response through a centralized dashboard. Modern cybersecurity is no longer about simply detecting known malware. Attackers constantly evolve their techniques, making static security solutions increasingly ineffective. Instead of asking, "Does this file match a known signature?" our system asks a more important question: "Is this system behaving abnormally?" That shift from signature based detection to behavioral monitoring is the core idea behind our solution. Before designing the solution, we first analyzed the problem. Traditional antivirus products primarily rely on signature based detection. This means they compare files against a database of previously known malware signatures. While effective for known threats, this approach struggles against modern attacks such as zero-day malware, fileless attacks, disguised executables, cryptominers, malicious USB devices, and suspicious process behavior. These threats often leave little or no known signature, making them difficult to detect. That's why organizations today require continuous behavioral monitoring, where the system observes how processes, files, and devices behave in real time instead of waiting for known signatures. To address these challenges, we developed the malicious threat scanner and response system. Our solution follows four fundamental stages: watch, detect, classify, and respond. The system continuously monitors endpoint activities, including running processes, file system events, and USB devices. Once suspicious behavior is observed, the detection engine evaluates the activity using behavioral rules and threat scoring. If additional verification is required, the suspicious file is validated through the VirusTotal API. Finally, the response engine allows administrators to take immediate actions such as terminating suspicious processes, quarantining malicious files, and generating security alerts. All of this information is presented through a centralized React dashboard. Now let's understand how the entire system is architected. We adopted a modular client-server architecture because it allows each component to operate independently while communicating through clearly defined APIs. At the presentation layer, we have our React dashboard, which provides administrators with real-time visibility into endpoint activities. React was selected because its component-based architecture makes it easy to build reusable, dynamic interfaces. To communicate with the backend, React uses Axios, which sends REST API requests to our Fast API server. We selected Fast API because it is asynchronous, lightweight, and provides excellent performance for real-time applications while automatically generating API documentation. Behind Fast API, our system is divided into multiple independent modules. Authentication secures access to the platform. The Monitoring Manager coordinates all monitoring services. The Process Monitor collects running process information using SUTL. The File Monitor observes file system events using Watchdog. The USB Monitor detects removable storage devices. All collected events are forwarded to the Threat Detection Engine. Suspicious files are then verified using the VirusTotal API before response actions are executed. Finally, all alerts and monitoring information are stored in SQLite using Skill Alchemy and presented back on the dashboard. This slide represents the complete lifecycle of a threat inside our system. Everything begins with endpoint activity. Whenever a process starts, a file changes, or a USB device is connected, our monitoring modules immediately capture the event. The detection engine performs behavioral analysis and assigns a threat score. If the activity appears suspicious, the file is verified through VirusTotal to obtain its global reputation. Based on both behavioral analysis and external intelligence, the system classifies the threat according to its severity. Once classified, an alert is generated and stored in our SQLite database. The dashboard retrieves these updates instantly through FastAPI APIs, giving administrators real-time visibility. Finally, administrators can respond by terminating processes, quarantining files, or recording incident logs. This entire workflow operates continuously, providing proactive endpoint monitoring. Every technology in our stack was selected to solve a specific problem. React provides a responsive user interface. Vito significantly improves front-end development speed through fast builds and hot module replacement. Tailwind CSS helps us rapidly build a consistent and responsive dashboard. Axios acts as the communication bridge between front-end and back-end. Fast API serves as the central back-end framework because of its high performance and asynchronous capabilities. Python was chosen due to its extensive cybersecurity ecosystem. For monitoring running processes, we used Psutil, which gives direct access to CPU utilization, memory consumption, process IDs, and process status. For real-time file monitoring, we integrated Watchdog, which uses event-driven file system monitoring instead of repeatedly scanning directories. SQL Alchemy simplifies database operations through object relational mapping, while SQLite provides lightweight, persistent storage, suitable for our prototype. Finally, VirusTotal strengthens our detection pipeline by validating suspicious files using global threat intelligence. Once the architecture was complete, we divided monitoring responsibilities into 4 independent modules. The process monitor continuously tracks running processes and resource usage. The file monitor detects file creation, deletion, and modification events. The USB monitor identifies newly connected removable storage devices, helping detect threats introduced through external media. These modules are coordinated by the monitoring manager, which acts as the orchestrator of the entire monitoring subsystem. This modular approach improves maintainability and allows additional monitoring components to be integrated with minimal changes. Detection alone is not enough. Once suspicious activity is identified, our detection engine performs behavioral analysis and assigns a threat score. To improve confidence in the decision, suspicious files are verified through VirusTotal, which aggregates results from multiple antivirus engines. Based on this combined analysis, the response engine enables administrators to immediately terminate suspicious processes, quarantine malicious files, generate alerts, and maintain an auditable incident log. This creates a complete detection-to-response pipeline, rather than simply notifying users about threats. The dashboard serves as the operational interface for administrators. Instead of viewing isolated logs, users obtain a consolidated view of endpoint activity. The dashboard displays live alerts, active processes, file monitoring events, network information, threat statistics, and visual analytics. This centralized visibility enables administrators to quickly identify abnormal behavior and respond efficiently. Our solution offers several advantages. It performs continuous monitoring rather than periodic scans. It provides near real-time detection through behavioral analysis. Its modular architecture allows future expansion without redesigning the system. The integration of VirusTotal improves threat verification. The dashboard provides centralized visibility, while automated response capabilities reduce reaction time. Overall, the system is lightweight, scalable, and designed for future extensibility. Although our prototype demonstrates the complete monitoring pipeline, we envision several future enhancements. These include integrating machine learning models for advanced behavioral classification, supporting Linux and Mac OS endpoints, expanding threat intelligence sources, enabling SIEM integration, deploying the platform in cloud environments, and supporting enterprise-scale multi-endpoint monitoring. These enhancements would transform the system into a production-ready endpoint security platform. To conclude, cybersecurity is no longer about detecting only what we already know. It is about continuously understanding system behavior and responding before threats cause damage. Through the combination of behavioral monitoring, modular architecture, real time analysis, external threat intelligence, and automated response, our project demonstrates a practical approach toward modern endpoint